Conic section part 6 hyperbola. We discussed if a plane parallel to the, suppose this is a cone, if a plane parallel to the double napped cone, we have seen that it is in double napped cone like this. If, if a plane cut parallel to x-axis, so it will make two figures like this side and this side, and one line will pass from this point. Okay, so this is the same figure that we get on cutting the cone by the plane parallel to axis. Okay, so this figure is called hyperbola. Okay, so this in this figure you see in 2D, that was in 3D, not 2D. You will find that this is the x-axis. This is x-axis. This one is x to x O. This is the origin actually. The T they have written C. This is x O x dash x axis and y O y dash y axis. And you will find hyperbola two curves. One is this side, one is another side, which is the you can say mirror image of this one. And these two curves intersect x-axis at 2 points A and A dash. So these are called the vertices. Before that, we have two axes in this one. Like in ellipse, we have seen in ellipse there were two axes. One is vertical, one is horizontal. This is called major axis and minor axis. But here the case is different. Here one we have this x dash. This is called the transverse axis. This axis is called transverse axis. Transverse axis. So it is at a distance of a. It is at a distance of a from the y-axis that we have seen in ellipse also. So it will have the same coordinates a0 and minus a0. Okay. Then another vertical axis you can see y dash. So transverse axis is the x-axis. Its equation is equal to y is equal to 0. Its equation will be equal to y is equal to 0. That we will see. I will give you all the formulas. So first try to understand this one. So here we have one vertical line y dash, and this is called conjugate axis. This is called conjugate axis, and we can imagine any point on this conjugate axis. Suppose somewhere we are imagining, suppose seeing this here B. So then equal distance we will take another point B dash, and this distance we are just considering as B. So on y-axis this will be minus B. So on y-axis x coordinate 0, so 0 minus B and 0 B. So 0 minus B, 0 B are the vertex. You can see the vertices of the conjugate axis, and these are the vertices of a hyperbola at x-axis. So vertices of a hyperbola on x-axis are a dash, and focus that is same as we have seen in the case of ellipse. A E0. This is the focus coordinate here minus A E0, and one point P is just make tracing this curve. This point is at a distance of PS from this and PS dash from this point. Okay. So and from directrix, there are two directrix. One is this one Z, this one directrix, another directrix. So this point will move from this fixed point and directrix so that it will have the eccentricity is greater than 1 here. Eccentricity will be greater than 1. Means PM upon PS. So here PM upon PS, that is eccentricity, is greater than 1. So PM will be more. So this distance will be more as compared to this distance. So then eccentricity will be greater than 1. Okay. Then we have, yes, just as you have seen the two focus here. So second focus and second directrix. This is first focus S. Its second focus is S dash. Similarly, Z is the first directrix. Second is Z dash. Second directrix. And the relation. So therefore, focus are this and second focus is this. The equation here it is written. You can see this. Here it is written. This is the equation of first directrix, and this is the equation of, not visible clearly, minus A by E is the equation of directrix. That is the same as in ellipse. So in hyperbola, that is same. Only this relation is reversed here. In the relation between eccentricity B and A, this relation B square is equal to A square. That was 1 minus E square. Here E square minus 1, because eccentricity is greater than 1. Vertices we have seen. Transverse axis, I told you what a transverse axis. Now, for foci, we discussed directrix equations. I told you what are the directrix equations. Okay, so these are the two. Center is the origin. Eccentricity, the relation of eccentricity, you can have that. This is the same way. Either you write like this or that. This is, either you remember this way or you can remember by this way. Eccentricity is equal to 1 plus B square upon A square. Same thing will come when you will solve it and you get the relation. This is the relation between AB and eccentricity. Length of lattice rectum. This is what we are talking about. The horizontal. This is our horizontal hyperbola. Okay, so now, so we have seen that the length of the lattice rectum is also same, 2B square upon A, and the equation of this hyperbola will be x square upon A square minus y square upon B square is equal to 1. In ellipse, it was plus. Okay. And distance, there is a theorem, the difference of focal distances of any point in hyperbola is constant is equal to the length of the transverse axis. Yes, transverse axis. This length of this transverse axis is A plus A 2A. A plus A 2A. That was in ellipse. Same length of A dash is 2A always. Huh? So they are saying that PS dash and PS, point, distance of a point from first focus, and see this theorem. The difference of the focal differences of any 2 points in the hyperbola is constant is equal to the length of the transverse axis. Yes, difference of these two distances, which will be bigger, S dash. So PS dash minus PS will be equal to always 2A. This is a theorem. Okay. So now we come to the conclusion that we have this equation. If hyperbola, yes, second type of hyperbola is this one. This is called the conjugate hyperbola. This is vertical hyperbola is not called vertical hyperbola. This is called conjugate hyperbola. And here again the A B B dash and A dash. This is our conjugate hyperbola. The value of A square and B square will extend. There the lattice rectum was 2A square upon 2B square. Here 2A square upon B. Because we are taking now B dash as 2B. Okay. Yani ki, I mean to say that conjugate axis, this is conjugate axis and transverse axis. The length of transverse axis, this length. Length of transverse axis, this is B, and here also B, that is B 2B. So the length, if you consider length, that is positive 2B. So its coordinates are 0B and 0 minus B. And equation will be changed. Here the equation will be x square minus, multiply in this equation minus, so it will become minus x square upon A square plus y square upon B square is equal to 1. This is the equation of a conjugate hyperbola. So we have this table. From this table, we can do any question here. This is first type of hyperbola: center, vertices, foci, length of transverse axis, length of conjugate axis, equation of the directrix, eccentricity, length of lattice rectum, equation of transverse axis, conjugate axis, focal distance, and difference of the focal distances. Okay, so this we will follow. These formulas we will follow. Just we have to check which type of hyperbola is this, whether this is simple hyperbola or conjugate hyperbola. Exercise number 11.4. Okay. What we have to find: the coordinates of foci, vertices, length of major. Oh, sorry, this is ellipse. Okay. So exercise 11.4 on hyperbolas. Okay. So find the coordinates of the foci, vertices, eccentricity, length of lattice rectum of the hyperbolas. Okay. So now we will take question number 1. As I told you, we have to recognize first which type of hyperbola is this. So first question is x square upon 16 minus y square upon 9 is equal to 1. So x square is positive and 1 is positive. So that means this is the first one, hyperbola, first type of hyperbola. Okay. So in this one, we have to find and compare the equations. So first of all, you can compare it with the equation. So standard equation of hyperbola, standard equation of hyperbola in this case is x square upon a square minus y square upon b square is equal to 1. So on comparing, we get a square is equal to 16 and b square is equal to 9. That is, a is equal to 4 and b is equal to 3. Okay. Now we have to find the coordinates of foci. So foci coordinates are s, we can write together, plus minus a e 0. So for that one, we need to find the eccentricity. And for eccentricity, the formula is eccentricity is equal to, for this one, 1 plus b square upon a square. Substitute the value. 1 plus b square is 9 and a square is 16. 9 by 16. 16 plus 9, 25 by 16. So this will be equal to 5 by 4. So you can see eccentricity is greater than 1. So eccentricity is less than 1. Eccentricity is equal to 1 for parabola. Eccentricity is less than 1 for ellipse, and eccentricity is greater than 1 for hyperbola. And what is eccentricity? Eccentricity is the ratio of the length PM, length of the point on the curve from the directrix upon the length from the focus, PM upon PS. And remember that will you will not find anywhere in your textbook. Eccentricity is 0 for circle because there is no directrix. This directrix will be at infinity. So if it is at infinity, the point will be at infinity. So therefore the it will become 0. So that is the so eccentricity is equal to 5 by 4 here. Okay, then find we can put the eccentricity in a, therefore the foci coordinates will be plus minus a, what is it, 4, and e is 5 by 4, 0, that is equal to s plus minus 5, 0. We got. Now the vertices. Vertices, you know that vertices are a dash, and vertices are coordinates of vertices are plus minus a 0, or a will be equal to a, you are taking right side, to a 0, and a dash will be equal to minus a 0. So that is here a is equal to a. What is the value of a? A is 4. So 4, 4, 4 0, and a dash is minus 4 0. Okay, and find the eccentricity. We got length of the lattice rectum. So formula for length of lattice rectum in this case is length of lattice rectum is equal to 2b square upon a. 2b square upon a. So 2 into b square is 9. Directly you can put 9 upon a. A is 4. So 9 to the 18 by 4 is the length of lattice rectum. Correct it. So this is SP upon PM. Distance from focus upon distance from directrix. So eccentricity is equal to SP upon PM. Okay, so that was the first question. Now question number 2. This is second type of hyperbola. How will you recognize? First write the given equation. Okay. Then after writing the given equation, you have to check it is compare it with the given two standard equations. Two standard equations are, first type is x square upon a square minus y square upon b square is equal to 1, and then conjugate hyperbola is minus x square upon a square plus y square upon b square is equal to 1. So this equation is y square upon 9 minus x square upon 27 is equal to 1. So this is the equation which can be written minus x square upon 27 plus y square upon 9 is equal to 1. So this is just similar to this equation. Therefore, it is a conjugate. It is a conjugate hyperbola, second type, conjugate hyperbola. Now its a will be a square, that is equal to a square is equal to 27. Therefore, a is equal to under root 27, 9 3 is 27, 3 root 3. And similarly, b square is equal to 9 and b is equal to 3. Eccentricity, first always find the eccentricity is equal to 1 plus a square upon b square. 1 plus a square upon b square. In the second case, you can see the formula. So this will be 1 plus a square means 27 upon b square is equal to 9. 9 3 is 27. 1 plus 3 and root 4, that is equal to 2 greater than 1. Correct. So eccentricity is 2. Then coordinates of foci will be equal to a 0 plus minus be. That is equal to s 0 plus minus b. Here b is 3 and e is 2. B into e, that is equal to 6. So coordinates of foci are plus minus 3 to the 6. Okay, then vertices are a 0b, that is equal to here 0 3, and you can write foci. Then here vertices a dash will be 0 minus b, that is here 0 minus 3 vertices. Eccentricity already did. Length of lattice rectum. So the length of lattice rectum is length of lattice rectum is equal to, in this case, the formula is 2a square upon b. 2a square upon b, so 2 into a square. A square is 27 upon b. B is 3. So 3 9s are 27, 9 2s are 18. The length of lattice rectum is 18.